This video is for review quiz 2.1 and 2.2, and this is really all about functions and understanding how to look at functions on a graph, what is a function on a graph, that kind of thing. So for this first question, it says, is this thing, this blue outlined rectangle here, is this a function or not? And you can always test if a graph is a function or not by using the vertical line test. So we just draw a vertical line in our mind wherever we want. And if the vertical line crosses the blue stuff, the blue graph, twice at any point, it can be at one point, it can be at an infinitely many, as long as there's at least one point, then it is not a function. And this one you can definitely see does cross twice, right? If we just cut a vertical line down through this, I mean, you could choose a bunch of different ones here, and it'll cross twice. Even the y-axis is a vertical line that crosses the blue rectangle here twice. So this is definitely not a function. It does not pass the vertical line test. Okay, for this next one, we do have a function here because every vertical line that you cross over this thing, it'll only cross it once. Even though it seems like this side here keeps creeping up and up and up until it's like a straight vertical line, it does not do that. It actually will always pass the vertical line test. If there's ever some ambiguity where you're not sure if it does it eventually, there's no reason to assume that it will. Any of the curious behavior in the graph itself will always be shown. They'll always show it on the graph. So you can assume that the rest of it is, works the way you expect it to. In this case, it does not violate the vertical line test eventually. So this is a function. It does pass the vertical line test. Okay, we're trying to figure out what is g of x equal to 7. So what x value gives us the function value of 7? In other words, what on the horizontal axis goes up to a value of 7? So you can actually just find points, right? Like if I tried 3 here, positive 3, it goes down to -9. So that's definitely not it. We're looking for positive 7, right? So we're going to actually go up to positive 7, which is right here. And we do not go right because the function is not defined there. It's going to be left. And we see this point right here. This point is hitting the y value of 7. So what x value gives us that? Well, just go down to the x-axis, -5. So if we plug in x equal to -5 into the function, we go up, and that is a y value of 7. So -5, 7 is the coordinate of this point, and so that means x equals -5. Hopefully that makes sense. All right, this is a great type of question because it's just kind of like analyzing the function, understanding how do we see the function and what can we do with it. So there is a few questions that are always kind of on these types of problems. What's the domain? What's the range? What's the x and y intercepts? And then actually finding certain values. Those values are based on the function itself. Just being able to find them. They're different than the ones we just did. When we just did was asking what y value of 7 gave us the x value. Like what's the x value that we want to find here. In these, we know the x values, 1 and 5, and we're trying to figure out what is the y value. So that'll come at the very end there. But for the first question, the function's domain is over what x values is this function defined on. So if we find any point on here, we drop it down to the x-axis, we see -2. -2 is in the domain because you can go up. In this case, we're going to go up for all these x values, up or down, wherever the blue line is above or below the x-axis. Those are all contained in the domain. And because the arrows point, that means this function goes off indefinitely in that direction. And that means every single one of these values, every single one of these x values that go down to -infinity, they will all find a corresponding spot on this blue line. We just can't see it because it goes off the graph. It does keep going that way. The same thing happens as to the positive x values, right? This blue line keeps going on diagonally upward, and this axis, you can find any point on this axis and you'd be able to go up to the blue line and so it's defined there. That means that every number on the x-axis is defined in the function's domain. So it's going to be the entirety of it, from negative infinity to positive infinity. Right? For the function's range, it's the same idea, except now we're looking at the y-axis. And here, we can see it, right, like 8 here. 8 is defined because I can go left to the function. I can actually also go right to the function. Eventually this line will cross that this horizontal line of y equals to 8. But that's fine. That's fine if it does it twice or even more than that. That's fine. What we want to know is, where is it not defined? And you can see it's defined all the way down until this point right here is defined, right? That's at y equal to 1. Once we go below that, everything down here on the y-axis is not defined, because I cannot go left or right to the function. The function is not defined down there. It's only in this positive area. And the lowest value it's defined for is y equal to 1. So 1 is the smallest value. That's where we're going to start our interval. We're going to include it because the function does hit 1. You can see that because there's a direct blue line right there, and then it jumps back up. If it was missing, you'd see an open dot, like an open circle. But you don't see that here, so it's defined there. And it goes off to positive infinity. And that's because as we go up for the y-axis, these things always go up and up and up and up and up. And eventually you'll be able to find any one of these values on the y-axis here will be able to go left or right, actually, to the function, and it will be defined there. So positive 1, and it goes up to infinity. That's the function's range. Okay, x and y intercepts. Where does it cross the x-axis? You can see here the x-axis is right here. This function never crosses the x-axis. Therefore, there is no x-intercept. The y-intercept, it crosses it right there. It will never double back. It will always keep going this one direction. And so this is the only y-intercept, and that is at 5. So we can just say 5. Okay, finally, we can do these, find the function values. F of 1 is the x value because it's being plugged into the function. It's the input, which is always the x values. 1 is right here on the x-axis. To find what f of 1 is, we just go up to the function. And it touches right there, which is at 4. So 1 goes up to 4. So that's going to be 4. And then f of 5 is right here. This goes up to 2. So x value of 5 goes up to 2. And that's all correct. There's a lot of these parts for these types of problems. So take your time, make sure you have it correct, and then if you get something wrong, go back, check, make sure you inputted everything correctly. That can be a very easy thing to get wrong. All right, which open intervals is the function increasing? Where is it decreasing? And where is it constant? So increasing, this should be intuitive. As you go left to right, the function rises. So as you go left to right, we go upwards. That's an increasing. As we go left to right, the function decreases. It means it goes down, it lowers. And then constant is just a flat line. So this function, the first question is, where is it increasing? Right here is flatlining, 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 and right here it starts to go up. Then at this point it goes up even further, and then it flatlines again. Now both of these intervals, it is increasing on because it's still going up. It doesn't matter that it changes how fast it goes up. All we care about is it rising or falling. So in this interval here, from x equal to 0 and x equal to 4, in this interval, we have an increase in the graph. We do not worry about the y values here. We're always concerned about what portions of the domain or what portions of the x-axis give us the increase in behavior. That's because the x values are the inputs or the independent variables the function is based kind of on the domain of the function, not on the range. So we're looking for what is the parts of the domain. So we're going to go from 1 up to 4. There we go. 1 to 4, is it increasing on? Oops, no. Where is it decreasing? You can see on this graph, it never falls during any part of this domain. So therefore, it is never decreasing. It's never falling. It is, however, constant on a couple parts. This first part, it flatlines, and it stops right here at x equal to 0. And then at x equal to 4 and on up, it also flatlines. So this thing goes off to negative infinity. So we're going to go from negative infinity up to 0. And then because these two things are separate, we're going to have to union them together with the union symbol here. And then this goes from 4 up to positive infinity. So you can see that these two sets are separate. They're separated by this 0 to 4 place, which is where it was increasing. This should be 0 to 4, not 1 to 4. My mistake. So it's increasing on this domain here, and this is all constant all the way on off towards negative infinity on the x-axis, and then all the way up to positive infinity on the y-axis, or sorry, on the positive x-axis. It's 4 to infinity. It's also constant. So okay, I think there's one issue here. Let me go check real quick. Okay, I found my issue. They actually don't want the union. They want the just separation with a comma. It should really be a union because that's the interval that it's on, but that's what they want for anyway. Let's just move on. So for this question, we have, we're asking what is the relative max and relative min? And that's just where is there a peak and where is there a valley? And so that's all we're looking for here. And you can see directly we have two of those, or we have one of each. We have a peak right here. That means there's a relative maximum there. And we have a relative minimum right here. This is a valley here. So you can also think of it as where it's increasing and then it stops and then it's decreasing. That's a peak. Decreasing, stops, increasing, that's a valley. So relative max, relative minimum. All we need to do is figure out where is the relative max. In other words, what is the x coordinate of the relative max? And then what is the relative max? In other words, what is the actual y value of that? So what's the coordinate of the relative max? The same thing is true for the minimum. So the function does have a relative maximum. It's at x equal to 1. This is 1 here because it's showing it by -5 up to 5 in steps of 1. So we have a relative max at -1. That's the -1 on the x-axis. And the actual value of it, these are from -70 to 70. So -70 is down here and 70. And each increment is 10. That's what this means. So 10, 20, 30, 40, 50, 60, 70. So this is where the relative maximum is at. Or this is the value of the relative max, I should say. And that is 10 because each one of these tick marks are 10. So the relative max is 10. Right? It does have a relative min. That's going to be at, we'll guess around at +3. Yeah, I guess it could be a little bit further, but it's not giving us any information on that. So we're going to assume that it's going to be what we can see. It's at an x value of 3. And what is it? It is, looks like -50, right? -10, 20, 30, 40, -50 here. That's the relative min value of that. Check. All right, let me see what I did wrong here. All right, I found my error here. We found the x coordinates of the axes, but the y coordinates, I guess they don't have them exactly on the grid lines. So we can find them though by plugging them into the function. So we found an x value of -1 is where the maximum is. And it looks like it's at 10, but it's actually just above 10. If we plug in -1 into the function, we get 2 times -1 squared minus 6 times -1, 18 times -1 plus 2. Doing all this work gives us 12. So it's just above the first tick mark. The same thing is true for the second one. If you plug in 3 into the function and do all the calculations, you're going to get -52. So it's just below that line there. So I guess for these type of things, you just kind of try to find where the x values are, and then plug them into the function here, and that'll give you your correct y values. All right, we have a graph here. We're looking for what is the symmetry of this graph. There's only 2 types of symmetry that we care about, and it's kind of overall symmetry based on the graph itself, not on the, I should say, the Cartesian coordinate system, not on the graph. This graph does have symmetry. It does not have one of these symmetries. It's actually going to be this. I'll show you why. This graph does have symmetry about itself, but we're looking at the overall graph. And there's not one of these 2 types. There is what we call reflexive symmetry. Namely, the graph, the function is reflexive over the y-axis. Right, this is the y-axis here. And you can see that it reflects directly across. If we spun this graph, like flip the paper over, it'd be the exact same graph. That's reflexive symmetry. The other type of symmetry is rotational symmetry. And this graph has rotational symmetry. You can see that if I rotate this 180 degrees, I get the exact same graph. So those are the 2 types of symmetry, and they're based on the functions x squared, which is the top one, and x cubed. X squared has an even power. X cubed has an odd power, which is where we get even and odd symmetry names from. This thing, it is the same graph as x cubed, but it is shifted off of the center origin point. It has to be rotationally symmetric about the origin, the very center of the grid. This is not. If I rotate 180 degrees, I would get something that's maybe like this. It looks very different. It's not the same graph as this, but it has neither even nor odd symmetry. Okay, we can also test symmetry not using the graph. We can use just the formula. And the way we do that is we just plug in -x and simplify. So f of x is 3x to the 6th plus 10x, or sorry, x to the 10, and then plus 4. We're just going to plug in -x into the function and simplify. So here we have 3 times -x to the 6th, -x to the 6th. Same thing as -x times -x times -x times -x, -x, and -x. 2 negatives cancel. These 2 cancel, and then these 2 cancel. And now there's no more negatives, so we have x times x times x times x times x times x. That's just x to the 6th. So -x to the power of 6 is the same thing as x to the power of 6. We have 3x to the power of 6. The same thing happens to x to -x to the power of 10. That's because 10 is an even power. Even powers will always cancel a negative out. So we get the same thing as x to the 10 plus 4. But this is the exact same thing as our starting function, right? It says 3x to the 6 plus x to the 10 plus 4. 3x to the 6 plus x to the 10 plus 4. That means this is the same function, f of x. So if we have f of -x equals f of x, this is even symmetry. That means it's that flip symmetry. So it has symmetry based on the y-axis. That's where it flips across. So that's what the second part is there. Now, the odd type of symmetry is where you plug in negative x and you get negative f of x. So it's just the negative of the entire function. And that's the same thing as odd symmetry, and therefore you have symmetry about the origin here. It's rotationally symmetric about the origin. So you'd say origin for odd. All right, last problem. You have a piecewise graph here. A piecewise graph is interesting because it kind of like talks about different domains, and you can have different graphs fit different roles, things like that. And all we're trying to do is graph this function and then find the range of the function. Okay, so for the first part, we have, I'm going to look at the x value to see -4, 0, and then above 0. So I want to make those the most important portions of my graph. I kind of move this y-axis over a little bit. We have 1, 2, 3, -4. This is of course 0. I'll give a couple above and below that. Okay, now we can actually figure out what does the graph look like. So when x is less than -4, the function is always 0. So strictly less than -4, the function is always 0. 0 is on the x-axis. We're not including -4, so we use an open dot. And then I'm actually going to put this in red here. We have an open dot there, and then the function is just 0. It's just flat lines at 0. The y-axis on 0 is just the x-axis, that entirety flat line. Now, -2, x if x is between -4 and 0, and it includes -4. So if x equaled -4, which is included in this second portion, you just plug -4 into there. -2 times -4 is +8. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. +8 is at -4. That's about right here. I'm going to use a closed dot there to show that it's actually defined at that point. It cannot be defined at both 0 and +8, because if it were, it would not pass the vertical line test and therefore would not be a function. Okay, continuing. If x equals -3, it's still within this second spot. -3 into there is -2 times -3. That's going to be +6. So -3 goes to +6. You plug in -2. -2 times -2 is +4. -1 times -2 is -2. And 0 is not included in this, but I can put an open dot there at 0. 0 into there, 0 times -2 is just 0. So we're going to have an open dot right there. So it looks like this flat line. That's the second part. The final part is x squared if x is greater than or equal to 0. So we start at 0. 0 squared is 0. So we actually can close this dot here because x squared does equal 0 at 0. If you plug in 1 into here, because 1 is going to be in this domain, 1 squared is 1. So 1 goes to 1. 2 squared is 4. 3 squared is going to be 9. And we get this graph here. This is called a parabola. That's the final piece of the piecewise function. So which graph looks like that? I believe it looks the most like D. Now, what is the range of this? The lowest value on the y-axis, the range deals with the y-axis. The lowest value on the y-axis is at 0. And everything above it, every number on this y-axis above 0 will always cross, or you can go right to the function. Every single one on up to positive infinity. This side doesn't even matter because this side takes care of it all, but you could also say it definitely 0 is in there because this thing hits 0 all the time. And then all the way up to 8, that would also be included in the range. And then everything above that, well, this thing contains it, so that's also contained in there. So the range is going to be from 0 up to positive infinity. Everything below it is not contained. You cannot go left or right to the function. So that is not in the range. So we're going to start with 0. We're going to include 0 because we know it hits 0 at x squared is 0 when x is 0. And it goes up to positive infinity. And that's correct.